All right, here's our first lesson for chapter 4. So chapter 4 we call roots and powers. Okay, it's going to be all about finding the roots, not necessarily squared or cubed. It could be any root, and powers. Okay, so 4.1 deals with roots in particular, and this is going to be a review mainly, right? So a root and its corresponding power. So make sure you write down the notes, right? And pause if I'm too fast. Are inverse operations. Inverse, right? They're opposite, right? If you adding, right, has its inverse, which is subtracting. Multiplying has its inverse, which is dividing. So same thing here. If you go 5 squared is 25, right? Square root of 25 is 5. So you square this and you basically square root, right? The index here is also 2. And so these are opposite operations, right? A radical symbol is used to represent, and some of this is review, right? A root. And I will just label the components here, right? So you have the root here, and there's a number here, right? This is called the index. Okay, and the number inside is called the radicand. Okay, this number inside is the radicand. This number that appears here is the radical, the index, sorry, and the whole thing, right? That whole root is called we call a radical. Okay, so if you're thinking radical numbers, it's square root, or not necessarily the square root, but the root of something. The index will vary, right? So example, right? Square root of 16 is equal to 4, right? Since, and some of this is a review, right? 4 times 4 is equal to 4 squared, right? So square root of 4 squared, there's technically an index of 2 there, so they cancel out and you end up with 4, right? So that keeps going. The cube root of 3 is 27. Sorry, the cube root of 27 is 3, since like, right, you have 3 times 3 times 3, which is 3 cubed. And so the cube root of 3 to the 3, if you have the same power and index, right, they cancel out, and that's equal to 3. Right, so it would cancel out all the powers of 3 if you had more terms multiplying in there. Okay, and then you have the fourth root of 16, which is 2. Fourth root, you may ask. Yeah, so get used to that, right? That'll be different. And we can write 16 as, if you wrote the prime factorization of it, is 2 times 2 times 2 times 2, right? Because 2 times 2 is 8, and another 2 is 16. That'd be 2 to the 4, right? Therefore, fourth root of 2 to the 4, right? If the power and the index is the same, you're just left with whatever is the base, basically, of the number, right? And that's basically what 4.1 is going to walk you through. Okay, it's gonna make you find, you know, the roots of like, it varies. The index will vary. Okay, And so that's what we're going to be talking about. So let's do some examples here. So the first skill is to estimate roots, because you'll be asked to arrange radicals from least to greatest, or in ascending order. And I think it's good to memorize some of the perfect squares, right? So perfect squares, it will be faster as long as you're familiar with them, right? Perfect squares is 1, 4, 9, 16, 25, 36, and right, I'm just squaring the natural numbers, right? From 1, this is 2 squared, 3 squared, 4 squared, and so forth. So I'm giving you the perfect squares, and I'm sure you recognize a lot of them. 11 squared, right? 12 squared, 13 squared, 14 squared. I know I gave you these already. And 15 squared. I think if you go up to there, that's a very good thing to have in your toolkit, so to speak. Right, so then you have perfect cubes. Right, that'd be 1 cubed, 2 cubed, 3 cubed, and so forth. Right, 4 cubed, 5 cubed, and 6 cubed. And that's, I'm going to leave it at that. And you have perfect fourth powers, right? So 1 to the 4 is just 1, 2 to the 4 is 16, 3 to the power of 4 is 81, and so forth. So 256, 625. So 5 to the power of 4 is 625. And if you think about it, 5 to the power of 3 is 125. If you multiply this by 5, right, then it would be 4 5s multiplying, you get 625. So maybe I will do one more. Perfect fifth powers. 1 to the power of 5 is 5. 2 to the power of 5 is 32. And that's it. That's all I'm going to leave it at. Okay, so good things to know. Estimating roots. Okay. So once you have these written down, so I've kind of put this in a box. It will help you to know these, okay? So estimating roots. Let's continue. When you're estimating roots, it's very helpful to have memorized these ones. For example, if I asked you to estimate the square root of 27, right? Keep in mind this has an index of 2. How would you do that, right? Since the index here is 2, right? We look at perfect squares below and above the radicand. Okay, remember radicand is that 27 in there. So imagine a number line, right? So imagine there's from here to here. We're imagining a number line, and we're looking at our perfect squares that are close to 27, right? So one below 27 would be 25, right? A perfect square would be 25, and the perfect square above it up here is 36, right? Whereabouts would you put 27? I would say right about there, right? That's 27 right there. We know that the square root of 25 is 5, right? The square root of 25 is 5, and the square root of 36 is 6, right? That's why it's good to know the perfect square. So 27 is going to be, the answer for 27 is going to be between 5 and 6. So you have to do this without a calculator, right? And we're closer to 5 than we are to 6 here for our answer, right? So therefore, the square root of 27, and you're estimating here, is going to be, actually we don't do equal, we go when you estimate, you go approximately, so you use the squiggly lines, right? And let's say it's about 5.2. Again, we're not gonna, if you said 5.3 or 5.15 or something like that, that's still close enough. But it's definitely not halfway between the perfect squares, right? So it shouldn't be 5.5 or 5.4. It should be more in the 5.2, 5.3 in terms of your answer. So that's when you're estimating, this is the approach you're taking. Okay, let's continue. And we're going to use this to order radicals, okay? Again, you can always pause if I'm going too fast. Example 2, order the following radicals in ascending order. That means from least to greatest, right? You're ascending, you're going up, right? And so let's say I had the cube root of 26, always watch the index. You had the square root of 10, and you had the fourth root of 19. Okay? So how would you arrange this? Well, you take each one of them individually, and we're going to use that estimation method that I just showed you, right? And for each one of them, you're looking at the index, okay? So for each one of them, you're going to be like, okay, this is a cube root, fourth root, and this is a square root, right? So perfect cubes, perfect squares, perfect fourths, right? That's what you're going to be looking at, okay? So I'm going to kind of break this down into 3 sections here where I'm going to do some work, okay, to show my work. So 26 perfect cubes, right? You kind of do your number line, right? And a perfect cube of 20, if you go at 26, let's go look at our perfect cube here, 26. So it would be between 8 and 27, right? Those are, because we're talking perfect cubes, because the index is 3, right? So it's between 8 and 27 that we know the perfect, we know the answer to those roots. So you put 8 and 27 here, okay? You know that the cube root of 8 is 2. You know that the cube root of 27 is 3. So those are the answers to those cube roots. 26 on this number line would be right about there, right? Or very close to 27. So therefore, the cube root of 27 would be 2.8, 2.9, would you say? Yeah. So let's just squiggly, right? 2.8. So we know approximately what that should be. Then you look at the square root, right? We do our number line too, because you're going to find the two numbers, the two perfect squares in this case, that are close to 10, right? So here you're thinking 3 squared is 9, 4 squared is 16. So 10 is going to be, right, square root of 9 is 3, and the square root of 16 is 4. and 10 is going to be right about there. Okay, so therefore the square root of 10 is going to be approximately 3.1, 3.2, right? Something like that, approximately. Then we go 19, and there we're looking at perfect fourths, right? So the perfect fourths that are close to it. And if you think about it, 1 to the power of 4 is just 1. 2 to the power of 4 is 16. So we're actually, that would be, right, the 19 would not fit between 1 and 16. So I actually have to start with 16, right, because 2 to the power of 4 gave me 16. So then you have to go 3 to the power of 4 goes here, right? And think about it this way. Sometimes it's easier to think about it as 3 to the 4 is 3 squared times 3 squared, right? And which is 9 times, 9 times 9, that is. So that's 81. Okay, so the perfect fourth, if you go through your number list, right? 1 to the 4 is 1, 2 to the 4 is 16, 3 to the 4 is 81. So these are your perfect power of 4. So 19 is going to be somewhere here, right? So I'll put this down. This is 10. 26 is right about there. And here you have 19 is right about there. So since the fourth root of 16 is 2, we know that the fourth root of 81 is going to be 3 because of this. Okay, so the fourth root, right? Therefore, I'm using the same method as I used in the previous page, right? The fourth root of 19 is going to be approximately 2.3, let's say. Okay, approximately. So now you've estimated all three of these radicals, and you know now by looking at the decimals which one the smallest one is. So we need to put down the fourth root of 19 first, because that gives us 2.3. And then we have cube root of 27, right? That's next. And then we have the square root of 10, which is 3.2. So now you've arranged it, okay? And this skill is important to understand how we did this, because it's going to be important to understand radicals and, you know, not just working with square roots and cube roots, right? So this is how this would be arranged, right? And so this would be showing your work, especially if you're submitting stuff online, ACs and whatnot. I'm going to be looking for that because you can't use your calculator for this, okay? Chapters 3 and 4 are non-calculator units, okay? And then evaluating roots, okay? We can evaluate and determine, it's the same thing, any roots, get exact values. So we're going to start with the easy ones. Square root of 36, that's 6. But what if there was another question where I asked you to find the square root of 0.36? Right? How would you do something like that? Decimals, right? So you got to watch out, right? Decimals. What we will do is turn into fractions. That's how we're going to do that, okay? We don't want to be taking roots of decimals, although you can probably estimate what it's going to be, okay? So what we do is we write 0.36, we write it as square root of, right, 36 over, and I don't know if you remember this, you count the decimal places, and that's how many zeros the 1 will be having at the denominator. So you start with 2 decimal places, so it's 36 out of 100. Okay. Then you're going to say, okay, well, now that I have a fraction, you can just take the square root of the top and the square root of the bottom. And this goes for any power, any index, right? I know that the square root of 36 is 6. I know that the square root is, they're both perfect squares, is 6 out of 10. And that you need to reduce. You need to reduce your fractions, right? So 3 goes into 6 2 times. Sorry, I'm off here. 2. 2 is the only number that goes into both of these, right? 2 goes into 6 3 times. 2 goes into 10 5 times. And that's when you're done. That is the answer to this question. And you know that 3 over 5 is 0.6, right? I don't know if you remember that, but it does work out. And then note roots of numbers between 0 and 1 are larger than the radicand. Just making observation here. Okay? Because if you think about it, 0.36, right? And 3 over 5 is actually 0.6. Your answer to this root here is actually greater. I don't know if you noticed that, right? 0.6 is bigger than the radicand that you started off with, and that's actually always going to be true. Okay. And so keep this in mind. Decimals, you break them down into fractions to get that. Okay. So C. So you have 16 over 81. That would just be square root of 16 over square root of 81, which is 4 over 9. And that you can't take any further. The square root of a negative 9 does not exist. Can't be done. And here's a big note here, which is going to be important for the rest of the unit, right? You can't take the root of a negative if the index is even, right? So this is very important. So what's an even index? Well, it's a square root, a fourth root, a sixth root, anything. If you have an even, like this would be a 2 here, right? 2, 4, 6, any even index, the roots, you cannot take negative, the root of a negative value. It just cannot be done. And here we have another one. Let's continue with one more example. E, the cube root of negative 8 is equal to negative 2. And that is possible because it's an odd, right? Negative radicand with odd index. Okay? There's an odd index there, so then you can do it. And just think about it this way. This is true since negative 2 times negative 2 times negative 2, right? These two will give you a positive 4, right? Multiplied by the negative 2 there, that would be negative 8, right? Because positive and negative is negative 8. So the inverse operation, right? Negative 2 to the power of 3 would get you back to negative 8. So you can always take the root of a negative provided the index is odd, okay? And I think I'm going to leave this at that. I'm going to give you the homework here. That would be page 206. And I'm going to go 1 to 5. And I might break this down into 3 videos. The next one will be a shorter one as well, but then I just break it down into, usually I do 4.1 and 4.2 together, but I will just keep it at this, okay? So just keep, I might post the 2 videos tomorrow or yet later today, we'll see. But just make sure you have this written down and do the homework for this, all right? And I'll see the other groups for the tests, and if you're not writing the tests, you're obviously watching the videos and writing down the notes and doing the homework, all right? Have a good one.